In this video we're going to look at something that's pretty simple and straightforward. It's the convergence of sequences. If you remember from previous videos, a sequence is a list of numbers that usually follows a pattern. And so for example we could have the sequence a sub n equals 1, 2, 4, 8, 16, etc. And in this case this pattern is 2 to the n minus 1. Now, what we want to know is, given a sequence, does it converge? And remember that convergence is, does the sequence trend to a number? So the way that we do this for a sequence is we basically just take the limit as n goes to infinity of the term a sub n. So if we do this from the previous page, we have the limit as n goes to infinity of 2 to the n minus 1. Clearly, if you do 2 to the infinite minus 1, you're going to get infinity. This sequence does not converge, so we say it diverges. Okay, pretty straightforward. So we can say that a series converges if, sequences and series are different. Sorry if I interchange them, I'll try to be careful with that. A sequence converges if, and let's call the sequence a sub n. So a sequence a sub n converges if the limit as n approaches infinity of a sub n is L. And L has to be a number, so not positive or negative infinity. Not plus or minus infinity. And this idea came up before in continuity. You know, you have the limit as something approaches something else. It has to be a number. This is our definition for a sequence to be convergent. So a sequence converges if it goes to a number. That's pretty much it. So to determine if a sequence converges, all you have to do is take this limit. If it goes to a number, great, you're done. If it doesn't, then it doesn't converge and it diverges. Pretty straightforward. Let's look at some quick examples. Usually you can do this by just doing Bobo-Botten or L'Hopital's rule or comparison of functions in your head. So let's say we have 2 over 4n squared minus 1. Clearly the exponent on the bottom is bigger. This limit is 0. This sequence converges to 0. Let's say that we have 3 times 1/2 to the n. If you notice that this is a geometric sequence because we have a common ratio of 1/2. As n goes to infinity, we basically have 1 over n divided by 2 over n. 1 to the n is just 1. And so we have 3 divided by 2 over n. This piece is going to go to infinity. This will also go to 0, so the limit of this sequence is 0. Let's say that we have n factorial divided by 2n factorial minus 1. Just like with exponents, really you could ignore any plus or minus a constant, and so this will go as n factorial divided by 2n factorial. The n factorials essentially will cancel, and the limit of this sequence will be 1/2. So yeah, so those are just some examples of what you can do to determine if the sequence will converge or diverge.